You type your CPU and GPU into an online bottleneck calculator. It gives you a scary 35% score, and suddenly you feel like you need to buy a new processor. Here's the truth. That number is completely meaningless. In the tech space, bottleneck has become a clickbait buzzword used to trigger anxiety and push hardware upgrades people don't actually need. In this video, we are going to dismantle the bottleneck myth, explain how performance limits actually work at the hardware level, and show you how to diagnose your own PC for free. Let's start with a fundamental rule of computer architecture. Every single computer system has a bottleneck. If it didn't, your frame rate would be infinite. The problem with web calculators isn't just that their algorithms are inaccurate, it's that a static percentage is physically impossible in physics and engineering. A bottleneck is dynamic, not fixed. It shifts constantly based on 4 key variables. First, resolution and rendering scale. At 1080p, the CPU works harder to prepare high frame counts. At 4K, the GPU becomes the primary limit. Second, APIs and engine design. A game running on DirectX 11 might saturate a single core, while DirectX 12 or Vulkan distribute threads across multiple cores. Third, in-game scenarios. Standing in an empty corridor makes your GPU bound. Entering a dense city filled with physics and AI instantly shift the load to the CPU. Fourth, memory latency. Slow RAM or tight timings directly dictate how fast the CPU feeds the GPU. Try to compress all of this into a single number like 35% bottleneck is complete fiction. To understand how performance actually degrades, we need to look at the 3 physical limits of modern hardware. First, GPU bound. This is what you want in most gaming workloads. Your graphics card operates at 98% or 99% utilization, rendering frames as fast as its silicon allows. Frame delivery is predictable, consistent and smooth. Second, single-thread CPU saturation. This is where most users get missed. You open Windows Task Manager, see 25% or 30% overall CPU usage, and assume your CPU isn't the problem. Games heavily rely on a primary thread. If your CPU has 16 cores and a game engine only utilizes 4, a single thread can hit 100% saturation, bottlenecking the GPU while the remaining cores sit idle. Task Manager averages all cores together, disguising the issue. Third, memory and bus bandwidth. Sometimes neither the CPU cores nor the GPU core is the constraint. If your RAM suffers from high latency, insufficient bandwidth, or if your PCI bus is saturated, the CPU stalls waiting for data. This manifests as sharp 100% low frame dips and micro-stuttering, which people frequently misdiagnose as a weak CPU. Instead of relying on web algorithms, you can diagnose your hardware in real time using free diagnostic tools like HWInfo64 and RTSS. Here is the 3 steps diagnostic method. Step 1. Check GPU core usage. Look at your GPU utilization. If it stays locked at 97 and 99%, you are GPU bound. Your hardware is balanced for that specific workload. Step 2. Inspect individual thread saturation. If GPU usage drops below 90%, expand HWInfo64's thread monitoring. Looks for any individual core thread bouncing off 100%. If one thread is maxed out while GPU usage drops, you are CPU or memory limited. Step 3. Analyze frame time consistency. Observe the RTSS frame time graph. A flat line means smooth delivery. Spikes on the graph coincide with memory latency on the PCIe bus congestion. Before you spend hundreds of dollars replacing hardware based on an arbitrary percentage from an online calculator, take 10 minutes to analyze your system's actual telemetry. Stop guessing, start measuring. If you appreciate logical, no-nonsense hardware analysis, consider subscribing to Rational Tech. Thanks for watching.